This is 8.3 notes, graphing reciprocal functions. That's how you say that word, in case you didn't know. Alright, so we're going to talk about transformations and then asymptotes again, and then graphing these with domain and range. So the first thing we're going to do is transformations. So let's go with some notes that we kind of know what we're doing, what we're talking about. So a reciprocal function is simply y equals, and I have 1 over x minus h, and then outside the fraction plus k. And yes, these are still fractions, that's okay. So let's do transformations. I have h and k. Y'all have seen h and k. We've done transformations. The rules don't change. They just look different for this. As everything else, it just looks different. So if I ever have x plus h, I'm going to shift to the left. Okay? See, that's always been the same rule. If I have x minus h, I'm going to shift right. Okay, that has not changed. If I have plus k on the end, I shift up. And if I have minus k, then I shift down. Okay, so far, everything's been the same. So we have left, right, up, down. The next thing is the vertical stretch, vertical compress, and that's with A. Now, it's the same rules, it just looks different because of how this function is written. Okay, so if I have A over x minus h, then I'm going to end up with a vertical stretch. So if I have some number on top besides 1, then it stretches. Now here's where it gets a little tricky. If I have 1 over a and then x minus h, that would be a vertical compress. So now some numbers on the bottom. Alright, so I can have a number on top, a number on bottom. Because technically, if I'm on the bottom, it's the same thing, and don't write this down unless you really want to. It's the same thing as 1 over a times my function. 1 over a, of course, is less than 1, which is why it compresses. The top is the same thing as saying a over 1 times my function, and that would make it greater than 1. That's why it's a stretch. So the rules didn't change, it just looks very different because of how the function is written, because it's a fraction. So now you're just looking for a number on the top or a number on the bottom. Okay, top is stretch, bottom is compressed. That's it. And then of course the last one, if a is negative, whether it's in the top or bottom, it doesn't matter. So negative a, whoa, that was terrible. That's not much better, but oh well. So reflects over x-axis. So if my a is negative, either on the top or on the bottom, it doesn't matter. It could be, I could have a negative up here. It's still, so if I have a negative, and I'm just going to tell you for this class at least, for this class, I'm going to put the negative with a. So you're only going to see the negative with a on the top or with a on the bottom. I'm never going to try and trick you for this. That's not the point of learning this. That's the more advanced thing. But just to learn this from nothing, because I don't think this is not an Algebra 1 thing. Brand new something here. I want to make it as easy as possible, but knowing that if you see a negative, it reflects. It flips the graph. Okay, so here's all of my transformations. So we have all the same ones that we've always had. I think the biggest difference is the A. Okay, just where the A is and how it looks, even though they do the same thing. Okay, so let's look at number 1. Of course, I'm always going to start with y equals and let's go through this. I vertically compress by 3. Okay, so if I compress, I know I'm going to have 1 on the top and 3 on the bottom with parentheses. Okay, and remember, I don't want you to, don't multiply this out, don't FOIL or whatever you want to call it, don't distribute. I want to see that you know where the compression goes. I want to see that you know where left and right goes if you have an H. Okay, so vertical compress by 3 is 1 over 3. Then I go 2 units left. Okay, so remember, going left, I would add the number. So in parentheses, x plus 2. And then last one is 5 down. So then outside the fraction on the end, down is minus 5. Okay, that would be my final answer for all of it. I compress by 3, I move left 2, and then down 5. Okay, number 2. I'm always going to start with y equals, and if I go through here, I reflect across the x-axis. So reflecting, I know I'm going to have a negative on top of my fraction. Well, I wouldn't say necessarily on top. So I'm going to have a fraction. Okay, I'm going to have x. So I need something on top and bottom. Okay. So if I'm moving too fast, I apologize. Let's start over. Okay, I reflect. That's the first thing that I see. So if I reflect, I would want to look for compress or stretch to know if I'm going to put the negative on top with a or on bottom with a, if I have one at all. But if I go through this, I don't have a stretch or compress, which means my reflection will I just put it on top with 1. Because if you don't have a stretch or compress, or if you don't have a stretch, your top number is always 1. Okay? So since I don't have a stretch, I don't have an a at all, the negative just goes on top. Okay, now let's continue. I translate 3 to the right. So if I go right, I would subtract that number. And then last one is I go 1 up. So then on the end, plus 1. And that is my entire answer. So transformations, again, most of it's review. The only biggest change, or I guess the only change, and it's a big one, is just where a goes and how it looks. Alright, next one. So asymptote. Remember, an asymptote is the imaginary dotted line that you never cross. So you never cross the asymptote. That's where it goes right up to the line. It curves along. Okay, we did those in the last chapter. So for notes, though, real quick, if I have y equals, and then 1 over x minus h plus k, okay, so I'm going to have 2 types of asymptotes on these functions. So last time we only had 1, now we have 2. So I have what we call a vertical asymptote. So vertical asymptote, which I always abbreviate with VA, because that's a long word, long 2 words to write. I don't want to write them every time. So vertical asymptote is always going to be x equals h. Okay? And if you remember, with h, just like with every other function, h always changes signs. So change sign. So if I have x minus 2, then it'd be x equals 2. Okay? And then my other one, if I'm not vertical, it's horizontal. So horizontal asymptote, which I abbreviate with HA, that one would give me y equals k. So let me specify. You only change h, you don't change k. So again, those rules have not changed. Just the function looks different, that's it. So now we want to write. We're going to be given the 2 asymptotes, and we have to write the equation. So let's go here. So again, I'm always going to start with y equals when it wants me to write a function. And I have x equals -4 and y equals 6. So the x you always want to change. So my VA is 4, HA is 6. Okay, so when I write my function, I'm going to do 1 over x plus 4, and then on the outside plus 6. Because really this is kind of like x plus VA, and then on the outside is plus HA. Okay? And of course if it was a negative it'd be minus. You don't always put plus, so don't do that. So that would be my answer, that function in red. Okay, so the next one. I have x equals 5, y equals 12. So I would do VA is actually negative 5, HA is 12, okay? So I write my answer as y equals 1 over x minus 5, and then plus 12. And that's it. So it just gives me the two asymptotes. I just have to plug them in correctly. So you have to put them in the right spot first off. H is on the bottom, K is on the side, on the right. And then you got to flip the sign of H. Those are the two main things to remember. Alright, last thing is graphing. Okay. So notice we have to graph, we have to do domain and range, and we have vertical and horizontal asymptotes we have to find. So we already know about the asymptotes. I'm not going to rewrite those. We just wrote the notes. But I will show you domain and range and how to graph. Okay, so again, my function, y equals 1 over x minus h plus k. Okay, so let's go through and do domain. If I want to write domain for one of these functions, here's how I would write this. I'm going to do it in set notation. So I have a little fancy bracket, and I'm going to say I have x such that x does not equal h. Okay, that's pretty much saying that it's every number except for h, because if that's my asymptote and I can't cross that point or that line, then I'm never equal to that number. Or in short terms, h goes there. Okay, h goes with domain. Remember to flip the sign. And then range, you might have guessed, I do fancy bracket. That one looked weird. So I have y such that y does not equal k. Okay, so h is domain, k is range, and you put not equals. Okay, that's how you do domain and range. And then, let's see, we already know vertical and horizontal asymptote, and then graphing. Okay, let me show you this. So we have all this space down here. So let's do this. Let's do so positive graph. So remember, if your a is positive or you just don't have a negative anywhere, the way I would graph this is I'm just going to make up asymptotes just so you can see. I don't want to put them on the actual line. It's really hard that way. So let's say I have an asymptote right here. There's my horizontal. Here's my vertical. If I have a positive graph, then so notice I've cut this pretty much into 4 corners, okay? A positive graph is going to start in the bottom left and go down, and then jump across diagonally and go in the top right and also go down. Okay, that's how a positive graph looks. The way that I always remember this is if I have a positive graph, I should be able to draw a line through my 2 lines and it'd be a positive slope. Okay, because I'm going up to the right. That's how I've always remembered it. So yeah, drawing a line through these 2, through the center, they have to be opposite corners. They can't be on both the top or both the bottom. That doesn't work. Or they can't be all on the left, all on the right. That's not a thing. So they have to be on opposite corners, and if I'm positive, I should have a positive slope, like if I draw a line through it, I should be going up. So drawing a line through these goes up, and then negative, of course, is just the opposite. So I have negative. So I have a graph. Again, I'm just going to make up asymptotes. Let's say I'm over here and here. So if I'm negative, I'm going to go in the top left corner and go up, and then the bottom right corner and also go up. And that way, if I were to draw a line through these, notice that's negative, I'm going down, and that's what they should look like. So positive goes up, negative goes down, and then we have domain and range. So this is what the graph looks like. That's domain and range, and we already know asymptotes. Now we can do these questions. Okay, so first thing I would do, anytime you see domain, go away, is go ahead and do your bracket, and then do x such that x does not equal, and then all you have to do there is find h and put that number in, because this first part right here is always going to be the same. So of course on here, h is the opposite, right? So 2, not negative 2. And then range, same thing. Bracket y such that y does not equal, and then you just have to find k, which is negative 1. So that's domain and range. Okay, before I graph, I'm going to go ahead and do vertical and horizontal asymptote. I'll use a different color so you don't get confused. So vertical is always domain, right? It's going to be the same thing. And then horizontal is always range. Those numbers should match up. So I'm pretty much going to write what I did right here, except I want to make it equal. So my vertical asymptote is what my domain is not. So vertical not highlighter. So vertical asymptote x equals 2, horizontal y equals negative 1. So it's almost the same exact answer, it's just domain and range is not equal, and then the vertical horizontal asymptote, it is equal. Okay, so now we have to graph this. First thing I would do is graph the two asymptotes that we have. I'll keep it the blue color so you can see. So vertical, x equals 2. So on the x-axis right here, right, I'm going to go over to 2, and I'm going to draw a vertical dotted line. Okay, horizontal is on the y-axis. That's why it starts with y, right? So look for y-axis. I'm going to go to y is negative 1 and draw a horizontal dotted line. Okay, so those are my two asymptotes. So notice I've cut this into 4 corners. And looking at my function, I don't have a negative on top. I don't have a negative on the bottom. So this is a positive graph. So I'm going to draw my 2 lines in the bottom right corner and the top left corner. Okay, because that would be going up. So if you draw a line through those, that's going up, that is positive, that matches. Okay, so that's number 5, and the last one for today, 6. Okay, so I have domain and range. First, fancy bracket, x such that x does not equal, and then we have h. That says x plus 3, so h is actually negative 3. Range, we got fancy bracket, y such that y does not equal, k, which in this one is 2. Okay, and then now we can do VA, HA. So VA, vertical asymptote, is x equals negative 3. HA, y equals 2. Okay, so now I got to put these asymptotes on the graph. So x equals negative 3. On the x-axis, I go to negative 3 and do a vertical dotted line. And then horizontal is y equals 2. So on the y-axis, I go to 2 and make a dotted line horizontally. Alright, now on this one, notice I have a negative up here. That means that instead of going bottom right to top left, I'm going to go top left to bottom right. And you're pretty much just drawing along the dotted lines, okay? And just make it curve. And that's it. So, I would definitely recommend to practice these. These are something brand new. You've never done this before. And like I keep saying, this chapter is probably the hardest one of the whole year. And if you aren't doing well, more than likely I can probably tell you, and you might, if you can just admit to yourself, I'm not doing well because I'm not doing the homework. I'm not practicing. So the only thing I can do is recommend that you practice. Do all the questions. The more practice you do, the easier this stuff gets. The quicker you get at it, the less you have to think on, oh, I see this problem, what do I do? If you do these, if you do the whole practice, all the homework, you'll look at this problem and then just be able to start because you've done it so many times, you just know what to do. Or even if you have to have your notes sitting next to you, you see a problem, if you've done it 20 times, you look at your notes and go, oh yeah, I remember this, and then you get it done. So please practice, please, that's all I can tell you to do.